Right, so earlier we talked about there being three major categories to circuits. We said there were series, there were parallel, and then there were complex circuits. Well, complex circuits are just a combination of series and parallel, so let's talk about series and parallel circuits. Now, a series circuit will only have one pathway for the current to flow. In other words, when the electrons leave the battery, there is only one possible way they can go to get back to the battery. If that circuit gets broken at any point, that means the current flow will stop. So you can see in the diagram, the negative terminal is here. When the electrons leave the battery, they would travel along the wire and go into this light bulb, then this light bulb, then this light bulb, then through the switch, and then back into the battery. There's no other direction for them to actually travel. And if we go back to our FET, we can see that I've got a simple circuit set up here. I've got a battery, we've got some wires, I've got three light bulbs here. And if I close the switch, we can see the light bulbs light up. We can see the electrons slowly moving through the wires. If I open the switch, the electrons stop. And if we look really carefully, we can see that the electrons come out of the negative terminal. They travel along the wire through the switch, into this light bulb, into this light bulb, into this light bulb, and then back to the battery. There is nowhere else for them to go. So if I open the switch, that means those electrons are stuck where they are. They cannot travel any further. So in a parallel circuit, we have more than one possible pathway for the electrons to go through. If an electron leaves the battery here or the negative terminal, it flows through the wire, and then you can see it hits a point here where it can actually go in one direction or another. It can travel through this bulb, or it can continue along the wire. And then it hits another point where it can go through this bulb, or it can continue along. And in this case, it would go through this bulb. Now, you may be asking yourself right now, well, if the electrons go through here and pass through this light bulb, what happens when it goes here? Would an electron try to go this direction? Would it try to go this way? Which direction is it going to actually want to travel? Well, something to keep in mind. When electrons leave a battery, when they go into a circuit, they are being pushed towards the positive terminal. They are going to try to take the pathway that leads them back there. So if an electron travels to this point and goes through the light bulb, when it hits here, the options are to go against the flow or to go with the flow into the battery. They're always going to end up pushed in this direction. All right. Now, if I were to remove any one of these devices, so if I were to say eliminate this light bulb, it's not going to have an effect on the other two bulbs. If I had a switch in here and I flipped that switch, those two bulbs would still stay lit. Let's take a look at what that looks like. So I have here basically the same circuit we just saw in the diagram, and you can see we've got a power source, a battery up here, and the electrons would leave out of the negative terminal, come along, and they hit a switch. Now, if that switch was closed, they would continue along to here, and they would reach this point where they can go either that way or that way. And if they go this way, they'll go through this light bulb and back to the battery. If they go this way, they'll hit another spot where they can go that way or that way. And if they go through here, again, they'll go through the light bulb and then back to the battery, or they can pass along here and go back to the battery. Now let's see what happens when we actually close this switch. Well, take a look carefully and you can see electrons coming out of the negative, coming along. And then, like I said before, we can see at this point, some electrons go this way, some go that way. And then we reach this point, and some electrons go this way, and some go that way. And you can see in each case, they travel through a load, and then they get back to this point, and they start going back towards the battery. And same thing here. They hit this point, and they go back towards the battery. Now, if I open the switch, all of them turn off. But what happens if I disconnect one of the light bulbs? What happens if I say disconnect this one here? If I cut that light bulb, notice the other two bulbs just continue on as if normal, right? So the electrons are still going to go this way or this way. At this junction, they don't go in this direction anymore because that pathway has been blocked, but they can still go this way. Now, what happens if I were to cut here? What's going to happen? Well, the electrons are still able to pass through here. but they can't travel in this direction anymore because they're dead ends. There's no way to get back to the battery this way. If I reconnect it, then the electrons will start traveling through that again. But you'll notice no matter which spot gets cut, there's always a pathway leading back to the battery. And so electrons are still able to travel all the way through. All right, so that is the difference between a series and a parallel circuit.